This is Ham College, episode 36 for December 31st, 2017. Ham College is brought to you by ICOM. Start the new year out with a bang with one of ICOM's new radios. Communications have never been so much fun. And by hamstudy.org, a great way to study for your next license exam. Good evening. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And boy, that'll be the last time we get to say that this year.
It will.
It's good to be back with you again.
It's probably a good thing this is the last time we're going to say it this year.
Yeah, probably is. Boy, it is cold outside here tonight.
Yeah, it is pretty chilly. It's not as bad as it was. I just got back from Tennessee, from near Gatlinburg, and it was really cold there. It was like 18 at night.
Wow.
And the high yesterday was in the low 30s. So it was pretty cold.
What did we talk about in the last episode? Do you recall?
That is a good question. I think we talked about some of the different modes, sideband, upper sideband, lower sideband, and then as far as electronics, I believe we did inductors, if I'm not mistaken.
It was impedance. Is what we discussed,
okay,
and you can, you were right about the first part there. Though we did talk about some of the different modes, AM, FM, sideband, and we did a little demonstration there, showing on a band scope.
Pretty cool. And you know, right after this, I saw a post in the Amateur Logic Facebook group, someone asking how they could describe what the single sideband was. So I referred them to go back. To watch that.
That was a good reference.
It's very timely.
And guess what we're going to talk about tonight?
Some more of it?
Similar, some more operator practices, and we didn't get completely through that topic.
Yeah.
And we didn't get completely through impedance either.
Yeah, I think we're going to pretty much finish them up tonight, though, I think.
I think so.
I think the impedance, anyway.
Yeah, and we've got a few little related items here to cover as we go along with it. Anytime we're doing a show live, we've got a chat room going on at the same time. If you'd like to join in, well, where can they do that, Tommy?
Well, you can join at amateurlogic.tv/chat. And once you get past the security, there's one of the little CAPTCHA things you've got to get through. But come join us there. There's quite a few people in the chat room. If you're watching the live stream, you're only getting half of the fun, so the other half's in the chat room.
I see a lot of our friends are in there in the chat room tonight.
Oh, yeah.
They're having a good time, and we will occasionally look down there and see what's going on. And boy, the subject now is anywhere from germs to beer to honey ham. You know, they're bound to be having.
That's quite the variety.
Yeah. Are you ready to get on into tonight's questions?
Oh, I'm about as ready as I'm going to get.
Well, I think that sums up my feeling on it, too. So let's get on into it and see if we're going to have any buzzers go off tonight.
I think I'm feeling it.
Okay.
I think it's going to probably happen.
It could happen. Okay. Well, the first question tonight, which of the following conditions requires a licensed amateur radio operator to take specific steps to avoid harmful interference to other users or facilities? A, when operating within 1 mile of an FCC monitoring station.
B, when using a band where the amateur service is secondary.
C, when a station is transmitting spread spectrum emissions.
Or D, all of these choices are correct. Okay, so which of the following require the licensed operator to take specific steps to avoid interference? When operating within 1 mile of the FCC monitoring station. That seems like that would be logical answer. B, when using a band where the amateur service is secondary. That's definitely the logical answer. Or C, when a station is transmitting spread spectrum emissions, which is going to cover very wide bandwidth. That's okay. We're going to have to go with D. All these choices are correct.
So you
Because
say
A through C are all plausible answers.
Okay. Well, everyone over in the chat room is saying it's B. And
And I think they're right, but I think the others are right too. I don't know. I may
find out.
I may get the buzzer here.
You are the dean.
Yeah, if I could still get the buzzer. Oh, I did.
Oh, you got it. That one threw everybody off there. When I was looking at this question, putting them into the steels here, the last one, or the spread spectrum one, I was not sure about. But yeah, you wouldn't want to cause harmful interference. You'd never want to cause harmful interference. And the FCC monitoring station, that's, you could almost think that's a fake answer there, but it's not.
Yeah. I could see where they came up with just B being the answer.
So that was kind of a toughie. We tripped up just about everybody on that one.
Well, I thought I tripped myself up too, because when I looked down and saw all the B's, I figured I was wrong.
Yeah.
You never
I
know.
had my fingers crossed. All right. Got one for me?
I sure do. How about this one right here? Which of the following applies in the event of interference between a coordinated repeater and an uncoordinated repeater? A, the licensee of the uncoordinated repeater has primary responsibility to resolve the interference.
B, the licensee of the coordinated repeater has primary responsibility to resolve the interference.
C, both repeater licensees share equal responsibility to resolve the interference.
Or D, the frequency coordinator bears primary responsibility to resolve the interference. This is kind of a tricky one here too. So then,
well, I don't know. I think I know the answer to this one, but it may just be because I remember it from when I took my test.
Yeah, they're kind of split there, and
Oh, they sure are.
yeah, which is I figured they would be kind of split on it. So I'm just going to ask you, which do you think it is?
Well, I think it's A. The uncoordinated one has responsibility to resolve it because I think because the coordinated guy is where he's supposed to be. Unless his equipment is faulty, it doesn't say anything about that. Then I think it's the guy that just is encroaching on the one that's was granted that piece of spectrum to use.
And you would think that is the answer to it. And so it's unfortunate that the questions fell the way they did tonight, because we could have just had a buzzer right there.
Oh yeah?
Yeah, I'm thinking it's C. Now, but I would agree with you. I've always heard that it's the coordinated repeater that if there's a dispute, they get the frequency and the other guy doesn't. The uncoordinated is one that'll have to go away. But I think in actuality, it's C. Both repeater licensees share equal responsibility to resolve the interference.
Yeah, I mean, I could see where C is the gentleman thing to do, right?
Mm-hmm.
I guess that's the right way to say that. But I think when it comes down to if both were stubborn, I think it would boil down to A. I don't know. Let's go and see what the answer is.
There were more people answering A in the chat room than there was C, but those were the only two answers that we got. So pretty sure it's not B. I mean, it's not going to be the responsibility of the coordinated guy exclusively. So let's see. It is.
We did get a buzzer on you.
Wah, wah, wah. Yeah. Okay.
You had me second guessing myself.
Yeah. Now, why did I think that was C? I guess I just read it wrong.
It seems like the right thing.
Yeah.
But I thought about that too, but then again, what I said a while ago, because if both are hard-headed and one won't give, there's got to be some deciding factor, right?
Yeah, I'm going to put an X by that one right there on my piece of paper to show that I missed it. So
Okay.
I'll have to study that one harder.
It happens. I'll probably have one too. Who knows? Mine
Yeah.
will probably be in the electronics part.
Yeah. You
Good
would kind of
chance.
say maybe it could be C, though. And I was in good company there, too. You know, there were
Yeah,
a lot of folks.
I mean,
that
I
were
could see
saying,
where you would pick C, but then again, in my mind, I was thinking about what if one didn't give?
Mhm.
Then what? So then that's when I boiled back up to A.
Yeah. Well, I could argue on this a little bit, but I'm not going to because it'll just muddy up the water for anybody who really needs
it's
to
still
know
not
the
going
real
to change
answer.
the fact that it's
Right.
A.
That's what I'm saying. So I just better let that go right there. But it is A. What can I say? All right, I'm going to give you a tough one here.
Okay.
No, actually, it's not very tough. I should pick out a tougher one, though. Which of the following statements is true of voice Vox operation versus PTT push to talk operation? A, the received signal is more natural sounding.
Or B, it allows hands-free operation.
C, it occupies less bandwidth.
Or D, it provides more power output. Oh, I guess I have to answer this one.
Yep.
Well, Vox versus PTT. PTT, I know the answer, but I'm just going to kind of reason out a little bit. PTT is push to talk. Receive signal. It's just gonna be B. I don't know how you would reason that out, but Vox is voice operated transmitting, and it allows hands-free operation. So you got to be real careful when you activate that, though, that you don't hit your finger with a hammer or something
Yep.
when it's turned on.
Yep. Everyone is saying that in the chat room. I'm agreeing with you too. That Vox gives you hands-free operation. And I'll also, I'll kind of say, yeah, be careful when you turn the Vox on your radio. I have on several occasions heard people snoring on the air.
Yeah, I've heard that too.
They went to sleep at the, in the shack, and
Yeah, and you got to be careful too, because if the kids run in and hollering, "Hey, Daddy," or whatever, or the wife comes in asking something or whatever, then
yeah,
that's coming over the air too.
yep. A lot of people run Vox though, and
It can
And
be
like
it can
it,
be
yeah.
handy. You just got to be kind of careful with it.
yep, just got to be aware.
I never have really used it much more than just testing it.
Me neither, but I know there's some good reasons for using it.
Okay, which sideband is most commonly used for voice communications on frequencies of 14 megahertz or higher? A, upper sideband.
B, lower sideband,
C, vestigial sideband.
or D, double sideband. Well, that's a good question there, and one that I do know the answer for, and most folks are getting it right over in the chat room. And we've talked about this on the show before. Remember, we brought out those band charts.
Yeah,
and
we sure did.
We looked at them and we talked about everything above this frequency is almost always upper sideband. Everything below it is almost always lower sideband when it comes to sidebands. I just happen to know that was the 40 meter band. 40 meters and below is just almost always lower sideband. So 14 megahertz, that's in the 20 meter band. That's higher. So I'm going to say it's A, upper sideband.
Yeah, I agree with you.
And there's no.
Apparently, everybody else agrees with you also.
Yeah, I think we had one dissenter in there maybe, but yeah, everybody else is saying it's upper sideband. And this is one of those things before I got my general or extra, and actually got on HF. This one I might have had a little trouble remembering.
Mm-hmm.
You know, once you're on there and you're using these bands, you just kind of, it just sticks with you. So it's upper sideband. It's A.
Mm-hmm.
So anything above, say, the 40 meter band, which is, you know, around 7 megahertz, the band's higher than that, it's going to be upper sideband. Lower than that, it's going to be lower sideband. However,
Yeah, and
there is an exception in there. Do you remember the exception? It's the 60 meter
meters.
band. Yep. Mm-hmm. So 60 meters that's a little over 5 megahertz, and instead of being lower sideband, that's actually upper sideband on those frequencies.
Yeah. So I wonder how those were actually chosen. I don't know of any technical reason why you would do upper sideband 14 and above, or lower, lower than that, or lower sideband lower than that. Do you know of any technical reason?
Well, I don't think we'll discuss that right now, since I think it may be coming up in another question.
Okay. Well, why don't we hold that for a little while?
We'll
then?
hold that one for a minute. Vestigial sideband. Do you know what that is?
I do not.
That's just something I thought that maybe tonight we might want to talk about. It's not used in ham radio at all, but you're going to see this come up as the answer in several questions here on your exam.
Okay.
We might as well look at what it is, huh?
Yeah, let's do that.
There's a chart.
Wow,
right there.
that is so.
Doesn't that explain it all?
That's it.
Now, if you look a little closer there, this is the old NTSC television system, analog television, where it says Luma carrier there. Say that's the frequency that the station is transmitting on. Now, the old analog television signals, the video, what do you think it was, Tommy? Was it AM? Was it FM? Was it sideband? How was the video transmitted on an old analog television? There wouldn't be any reason that you would know this.
No, I don't know. I guess I always assumed it was just kind of AM.
And it is AM. You're correct on that. Luma, that's luminance. That whole gray area there. On a black and white television set, that's the spectrum that it's occupying. If you look all the way out there to the right, you see that little sort of pink area there, the audio carrier. That's where the audio rides on an analog television signal. It's transmitted as FM. It's not as high a deviation as a FM radio signal. It's a little lower deviation, but it's actually a separate carrier. On the analog televisions transmitters, they had one transmitter that did the visual portion and another transmitter that did the audio. And
that's interesting.
So it's a separate carrier out there, a separate FM carrier that does the audio. Now you see the red area there that says chromas, chroma carrier.
Yeah.
And if you look at those numbers across there, there's numbers pointing at that to say 3.579545 megahertz. That is a color burst frequency. And you will notice if you get to looking in some catalogs, if there's any crystals around, you're going to see more of that crystal than anything else, because that was used to tell a TV set that this is a color transmission you're receiving. If it saw a little subcarrier there or at 3.579545 megahertz, it would know this is a color broadcast decoded. And then that whole red area there is where the chroma information, the red, black, and green information of the television signal rides.
Well, that's interesting.
And
that's
that whole gray area there is where the black and white image is, and then it just superimposes the colors on top of that if you happen to have a color set. So black and white sets would just ignore that red area there that says chromas. Now, if we look back there at that thick black line again, Luma carrier, everything we've been talking about so far is the upper sideband, frequencies above our actual video carrier frequency there. You'll notice there's a little bit of area there on the lower sideband too, but it's chopped off. It doesn't go nearly as wide as the upper sideband.
Mm-hmm.
As a matter of fact, it only goes about 1.2 megahertz wide, where the upper sideband was 4.5. So, that whole TV signal is taking up 6 megahertz there. There's a little 250 kilohertz guard band between each of the channels. They really didn't need both sidebands to make the video signal, so they only included a small portion of the lower sideband, and they call that the vesicle sideband. And so that's what it's talking about. This signal right here is a vesicle type of transmission. In other words, one of the sidebands is not as broad as the other, like a traditional AM signal you would think of.
Okay. I've never even heard of that term before today.
Yep.
So that's pretty interesting to know. That's amazing. That's pretty amazing that how they did that. The little audio carrier is actually fairly matched to the video signal. So it seems like you might tune the audio way far off before you could get a picture, or the other way around.
If the tuner was not aligned correctly in your television receiver, that could happen. And I'm sure everybody who's familiar with analog television with the old analog tuners has noticed that sometimes you can get a good picture or you can get a good audio, but it's hard to get both at the same time.
I remember getting good audio and no picture or not much picture, but I don't remember getting it much the other way. That's pretty cool.
Yeah, I actually worked for a Channel 6 television station for about 5 years. Channel 6 is just right. That audio signal we were looking at there is just right below the FM broadcast band. So most FM receivers would actually tune to that Channel 6 audio carrier there.
Okay.
So you could actually pick up that television station on your FM radio.
Yeah, I remember listening to some television stations on the radio before.
Yeah. And that's why that worked.
Cool stuff.
Anyway, vesicle sidebands.
Now you know.
Yep. Now you know. Useless information, for your amateur exam, but at least you'll know when that answer comes up.
But now you know.
Yeah.
You're not going to think it's just some word they just made up, stuck on the test.
Yeah.
Which could happen.
Yeah, but there is actually such a thing.
Cool stuff.
Okay, and now let's see. I think I answered the last question. So I'm going to ask this one of you.
Okay.
Which of the following modes is the most common use for voice communications on the 160 meter, 75 meter, and 40 meter bands? Is it A, upper sideband?
B, lower sideband.
C, vesicle sideband, whatever that is.
Hey, I can show you a slide. Or D, double sideband. Well, we just discussed this just a few minutes ago. So I'm going to have to go back to my Ham College education from 5 minutes back, and I'm going to go with B, lower sideband.
Yep. I'm going to agree with you too. Most folks are saying B over in the chat room there. Let's just see if it is before we talk any further about it.
Okay.
And it is.
Okay.
Lower sideband. You get that one. Those numbers are all higher. I said earlier the 40 meter band and up, or everything above the 40 meter band was going to be upper sideband. And you'd think, well, maybe 160 meters, that would be above 40 meters. But no, it's not. When we're talking about the meters, those are inversely proportional to the frequency. The bigger, or the more meters, the longer the wavelength, but the lower the frequency.
Right. So 40 meters, 75 meters is like 3.5 5-ish, 6, 7,
8.
8.
Yeah. Hmm.
And then
9.
60, and then 160 is 1.6-ish megahertz.
1.8.
Is it 1 point?
Yeah.
I hadn't been down there in forever and ever.
Yeah, 1.6 is actually the top end of the AM broadcast band.
Don't
So.
transmit there.
Don't know.
Yeah. Okay.
All right, next question.
Which of the following is most commonly used for single sideband voice communications in the VHF and UHF bands? A. Upper sideband.
B, lower sideband.
C. Vestigial sideband.
Or D, double sideband. Well, all those answers seem very familiar there.
Yeah, except we just discussed the answer to this.
Yeah. Which of
So
the
we're
following
gonna
is most
find-
commonly used?
We're going to find out if your rule holds true.
I'm going to stick with my rule. I'm going to say it's A, upper sideband.
Okay.
But I'm also going to cheat and look over here and see what they're saying in the chat room, because I haven't really run hardly any VHF and UHF sidebands.
Yeah, me either. I did that when I got my first multi-mode,
Me too.
basically all band, all modes rig years ago, just to test it out, and I haven't done it since.
Yep. Well, let's see if we're right. Everybody in the chat room is saying it's A. And it is.
Cool.
So
And I would like to do some, but I don't have the antenna set up to do it.
I don't really. And why? And you say you don't have the antenna set up.
Yeah, because
Why
you
do you say that?
really need a horizontally polarized VHF or UHF antenna to do it, and mine are vertical.
Yep, because just all FM and I assume AM transmissions on VHF and UHF are on a vertical antenna. The guys going sideband, they were doing it horizontally.
Mm-hmm.
And I've never really got a good answer on that. Why do they do that? I guess other than, well, maybe it's less interference.
Yeah, that's possible.
Because everybody on
because,
FM.
because if they're on horizontal and you're on vertical, you're just basically pretty much not going to hear them unless they're very close.
Yeah.
That's the problem. Why I haven't done it.
Yep. Okay, well, let's move on. Which mode is most commonly used for the voice communications on 17 meters and 12 meter bands? Is it A, upper sideband,
B, lower sideband,
C, vestigial sideband,
or D, double sideband? They're just wearing those same four answers out.
Yep,
Okay, so I'm going to go with your same rule, and we know 40 meters was the cutoff point for lower, so this has got to be upper sideband.
so you're saying A.
I'm saying A, upper sideband.
Yeah, that's what everybody's saying over in the chat room. I'm going to agree with you. And it is. That rule holds true.
Yeah,
Except everything but 60
except for
meters.
the one case, and you know the exception to that. So make a mental note of that, and you'll be good on these questions when you take your test.
Yep. Okay, and one more question of this type tonight.
Which mode of voice communication is most commonly used on the HF amateur bands? A, frequency modulation.
B, double sideband.
C, single sideband.
D, phase modulation. Which mode of voice communications is most commonly used on the HF amateur bands? It's not FM, because FM is hardly used at all on HF, although it is used some on 10 meters. It's not double sideband, because I don't ever remember seeing anybody running that. You could, but I don't ever remember seeing anybody run that on HF. C, single sideband. Well, we've been talking about lower sidebands and upper sidebands. I'm pretty sure that's the answer right there.
Mm-hmm.
Phase modulation, that's pretty much not used at all for voice communications on HF. So I want to say it's single sideband. Everybody's saying that over in the chat room. Do you concur?
I do. I will say that at some point in time that changed, because that would have been CW at one point.
Not for voice.
Oh, voice communication. Stir. I got to read the rest of.
Yeah.
There's a good tip for you. Read the entire question.
There you go. All right. We're going to be back in just a moment because I got to load up some more questions here. But first, let's get a message from the folks who help make Ham College possible. Happy New Year's from ICOM. Start the new year out with a bang with one of ICOM's new available products. Communications have never been so fun. The SDR you've asked for is here. ICOM's new 7610 is a high-performance RMDR with the ability to pick out the faintest signal, even in the presence of stronger adjacent signals. The new ICOM IC7610 is a direct sampling software-defined radio that will change the world's definition of a SDR transceiver. RF Direct Sampling System, 110 RMDR, independent dual receivers, and dual Digicel. ID31A Plus, a new D-Star communications device, is here. Easy to operate, the ID31A Plus is available in silver, red, or gold. Worldwide digital communications. Share pictures and text messages. IPX7 waterproof, compact, lightweight, and tough. Visit icomamerica.com/amateur for more information on all the great ICOM radios. And thanks, ICOM, for making Ham College possible.
Yep, absolutely.
And at this point in the show,
About that time.
it is about that time.
To give away some ICOM swag. ICOM's kindly donated a ICOM ball cap and another ICOM Ham Crew t-shirt.
And it's a whole swag package. Jesse is going to stuff more stuff in that box besides just the t-shirt and the hat.
Oh, yeah.
You're going to get a band chart in there, I think, and some other literature, and really don't know what he's going to put in there, but for sure you're going to get a hat and a t-shirt.
Yeah, they got some pretty cool swag too. So you can probably find some really good goodies in there.
So before
goodies.
Before the show tonight, I drew a lucky winner here. And it is Greg, KD2OXX, and he said, please enter me in the drawing for the shirt and cap. I passed the technician exam after watching all the episodes of Ham College this fall. I received my call sign in time to celebrate Christmas. Thanks, Greg, KD2OXX. Congratulations, Greg, on 2 accounts there. First of all, on surviving all episodes of Ham College in one season.
That's something to brag about.
Yep. And then passing your technician exam.
That's definitely something to brag about.
That
too.
is.
Yeah, congratulations.
And congratulations on the ICOM swag package here. They'll be getting that out to you right away. As a matter of fact, I've already seen corresponding with Jesse at ICOM and passing off the size he needed and address and all of that. So, by now Greg knows that he's won and the prizes are on the way.
Oh, cool. Yeah, they don't play around with that. No. So, and so how can other people win?
Well, if you'd like, not you, but if everyone watching would like to win, everybody but Tommy, because I happen to know Tommy already has a hat, and he did have a T-shirt.
Yeah. Got lifted.
Don't know what happened to that T-shirt.
Yeah.
But if you'd like to win it, well, all you got to do is send us an email to hamcollege@amateurlogic.tv and just do like Greg is doing right here. Just tell us you want to be in the drawing and anything else you want to tell us.
Yeah.
We're not picky.
Yeah, you don't have to have a license. All you have to have is email and a name.
Email address and a name.
Yep. So let me ask you a question. If I entered this month, do I need to enter again for next month?
Yes. You need to enter every month.
Yeah.
Because we draw just right before the show each month, and all the old entries are wiped out in their history.
Yeah. And they literally are wiped out, just so we've mentioned this before. When you send your email in there, they go nowhere. The ICOM doesn't even get them. They just get the one winner.
The one winner, so they'll know how to correspond.
So they're totally deleted. We don't keep them ourselves, and we give them to no one else. So your email's safe with us.
Yep. 100%.
Yep. So get your entries in, and hopefully you win it next month.
Well, you ready to get back into a few more of these sidebanded
I'm about as ready
questions?
as I was when we started the last round of them.
Okay, that's
So-
good enough for me.
Okay, then.
Which of the following is an advantage when using single sideband as compared to other analog voice modes on the HF amateur bands? Is it A, very high fidelity voice modulation?
B, less bandwidth is used and greater power efficiency.
C, ease of tuning on receiver and immunity to impulse noise.
D, less subject to interference from atmospheric static crashes. Okay, so I'm gonna go ahead and answer this one because we talked about this a good bit last month.
Did we?
This exact
Yeah, I think we did. Yep.
when you use single sideband, it uses less bandwidth and greater power efficiency. So you can talk a lot farther with less power using single sideband,
Yep.
and use less of the spectrum.
Yep.
So we talked about that. So the answer is going to be B, less bandwidth use and greater power efficiency.
And apparently we made a big impression. Everybody got that right over in the chat room, but I think they
Yeah, now
they probably
Jeff is
already
kind
knew
of
that.
scared the atmosphere is going to crash. It says it right there on 4 on D.
Yeah. I'm not sure why, but we'll keep our fingers crossed on that, Jeff.
That could be bad.
Well, let's see. Yeah, less bandwidth used and greater power efficiency.
All right.
That's a pretty good reason.
Yay me.
Yep. Next question.
That's some more of my ham college education right there.
There it is. You know, you don't get to be dean for just showing up.
All right. Which of the following statements is true of the single sideband voice mode? A, only one sideband and the carrier are transmitted. The other sideband is suppressed.
B, only one sideband is transmitted. The other sideband and carrier are suppressed.
C, single sideband is the only voice mode that is authorized on the 20 meter, 15 meter, and 10 meter amateur bands.
And D, single sideband is the only voice mode that is authorized on the 160 meter, 75 meter, and 40 meter amateur bands. Well, let me read that question again. Which of the following statements is true of the single sideband voice mode? A, only one sideband and the carrier are transmitted. No, that is not true. That is false, and the reason why is because on single sideband, the carrier is gone. We're not transmitting the carrier. We're just transmitting a single sideband. So B, only one sideband is transmitted. The other sideband and carrier are suppressed. I'm going to say that's the answer right there. C, single sideband is the only voice mode that is authorized on 20, 15, 10 meter amateur bands. That's not true, and neither is it D. It's the only voice mode authorized on 160, 75, and 40 meters. You know, you can also run AM on those bands.
Oh, yeah.
I'm going to say it's B. Only one sideband is transmitted. Other sideband and the carrier are suppressed. Everybody over in the chat room is saying that. So let's see. Yep. It is B.
Way to go. You nailed it.
Nailed it shut. Okay, one more question here of this type, and I think we will be finished with the sidebands. For this week, anyway.
Both sides of the sideband.
Yep.
Okay.
Although we've been kind of leaning to the lower sideband most of the episode.
We have.
Why do most amateur stations use lower sideband on 160 meters, 75 meters, and 40 meter bands? A, lower sideband is more efficient than upper sideband at these frequencies.
B, lower sideband is the only sideband legal on these frequency bands.
C, because it is fully compatible with an AM detector.
D, Current amateur practice is to use lower sideband on these frequency bands. I guess that's what I asked earlier, isn't it?
That is what you asked earlier.
Lower sideband is more efficient than upper sideband. That's not true. Lower sideband is the only sideband legal. That's not true either. The answer is going to be D. Current amateur practice is to use lower sideband on these frequency bands.
And I'm gonna agree with you.
I don't know why, other than I saw when I mentioned that earlier, somebody said gentleman's agreement, and I guess somewhere along the path there, somebody started using it, and everybody just kind of stuck with it.
Yep. And then the people that went up to bands higher than 40 meters for some reason decided to use upper. So, yeah, I'm going to agree. It's D. Current amateur practice use lower sideband on these frequencies, and so really there's no technical reason.
Yeah, I wouldn't. When I was asking earlier, I just couldn't think of any reason why. It had to be something like that.
Yep.
Interesting.
Okay, we've got some electronics to talk about, and we're going to do that in just a second. But first, are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stuffelbein, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam.
Good evening, folks, and a hearty welcome to our drive-in theater. We have a wonderful evening's entertainment lined up for you, one that will provide pleasurable relaxation and diversion for you and your family. Did you fail to dress up for tonight's show? No tie, an old shirt and slacks, a house dress? Well, don't give it a thought. We're glad you came as you are. We just want you to enjoy yourselves.
You've got the whole world in your hand. You've got the whole wide world in your hand. You've got the whole world in your hand. You've got the whole world in your hand.
Put the whole world in your hand with Radio Shack's new portable cellular phone. A price and technology breakthrough.
You've got the whole world in your hand.
Only at Radio Shack, the technology store.
Don't forget to visit our refreshment center during the intermission or any time. You love the tasty array of snacks we have to offer. So will the youngsters. Everything is quality and so good.
Here is the all-new Super Shelvador, made only by Crosley. Inside and out, it's a wonder. For example, only Crosley gives you the beverage server. Want a cold drink? Help yourself right through the door. And only Crosley gives you the coffee miser. Watch. One press of the button, and you get an accurately measured tablespoonful. You don't waste a speck. The coffee miser fits into the Crosley deep door, where it keeps your coffee as fresh as the day it was opened. And with the price of coffee sky high these days, you want your supply to stay fresh, so you can enjoy it down to the last drop. The coffee miser and the beverage server are only two of the many exclusive features that make this beautiful Crosley Super Shelvador the most convenient refrigerator in the world. Be sure to see it. The all-new Super Shelvador, made only by Crosley.
Chevrolet for 1960. Outside, every styling accent refined and polished to a new degree of perfection. Inside, more relaxing room. The transmission tunnel has been shaved to give more room for the passenger riding in the middle. There's solid comfort throughout, a quieter, smoother ride, and the elegance of Body by Fisher. And Chevy sets the pace with lower prices for 1960. Based on manufacturers' suggested retail delivered prices, this Bel Air V8 sedan with turbo glide, push-button radio, and deluxe heater lists for $65.30 less for 1960. So start the 60s right with the finest Chevy ever, the superlative 1960 Chevrolet.
And now, on with the show.
Ooh, I just made it back from Brody's drive-in.
Well, you're
Just
still
in the nick
full,
of
aren't
time.
you?
Yeah, I am stuffed.
Well, it's open to 1 a.m., so we still got time that we can make
We
another
can swing
swing.
by
through.
there and get a cup of coffee when we finish.
Yep. Oh, that was fun.
Yeah, the Chevrolet commercial. I'd like to get one of those in mint condition now. That'd be pretty. I bet
Yeah.
that's worth some money.
Yeah. And those shoes she was wearing, man, you could kill some roaches with those, couldn't you? Yeah, I mean, get right up in the corners.
Yeah, those old commercials are awesome. Those cell phones, it's just hilarious. Those big cell phones like that.
My boss had one of those.
And those were small ones. They used to
Oh,
have
yeah.
the ones they had to have in a like a little suitcase looking, almost like a briefcase with a.
Mine wasn't quite that big. I had a bag phone, though, and it was,
Oh yeah.
it was a little bigger than a cigar box.
Yeah, do you remember those? The ones that were like on those. It was basically a big battery, and a handle on it, and the phone set on the front
Yeah.
of it, and had a little antenna on the
Yeah,
back.
I think we had maybe one of those on there the last couple of months.
Yeah, my dad used to sell those things a long time ago when they first came out.
Yeah. I know somebody in the chat room was talking about the shoe phone, you know?
Get Smart.
Yeah,
Uh-huh.
that would have been nice to have had. I'm not sure who you would talk to, and, it might get kind of odorous
Just
talking
wanna
on the...
yeah, you might want to just do texting.
Yeah. Okay. Well, let's get on back into the questions here. I think,
Time to get at the soldering iron. And,
getting close to it.
okay.
At least we'll get some components out here and talk about them.
All right.
First one here, and I don't know who should ask this one. I'll ask you.
Okay.
Which of the following devices can be used for impedance matching at radio frequencies? Is it A, a transformer,
B, a pi network,
C, a length of transmission line?
or D, all of these choices are correct?
What do you think?
Well, I know you could use the transmission line and the transformer. Yeah, you can use the transformer. And I'm not sure about the pi network. I'm assuming that because I think the two are that the answer is going to be D,
All these choices are
pi
correct.
network.
Okay.
Yeah, all these choices are correct. I'm honestly not sure exactly what pi network consists of.
Okay. That would have been something good to have a picture of at this point in the show.
Mm-hmm.
I don't, but it would have been good.
Oh, I just knew you were about to pop one up there
No, but I'm going to make one.
right quick.
But first, we're going to look at see
Okay.
if we even need to talk about that. Yeah, all these choices are correct.
Okay.
Okay, so You got that.
We just so
You
happen
said,
to have a piece of paper.
I just so happen to have a piece of
Borrow
paper.
my ink pencil.
I got an ink pencil right here too.
Okay.
All right, a pi network would typically be something like this, and yeah, you can't see while I'm drawing. You'd have an inductor, and then you would have two capacitors going to ground, or that's just one type of pi network. So it's a coil and two capacitors
Okay.
hooked up like this, and they call it a pi because it looks like the symbol pi.
Oh. Well, that's crazy.
Yeah. You know, the symbol pi.
Yeah. I'm
Sort of
familiar
like
with
that. Yep. The type that you'll most commonly see in an antenna tuner would the ones that have like an inductor and two capacitors on it
Uh-huh.
typically is going to be like this. It'll be a capacitor, and then the coil will be in the middle and go to ground. And you'd call that a T network, and that's a variable. All those are variable components. And that's because it looks like a T.
I'll have to go back and look at last month because I think we discussed some of this last month now that you're doing that because it's coming back to me a little bit.
And also another type of poplar matching might be an L network. There's a more than one way you can do that, but say one common way might be like this. You got a capacitor, and you got an inductor to ground, or you could have an inductor here and a capacitor to ground, just depending on what you were trying to do. And they call that an L network because in this case, it's like an upside down L.
It's a 7 network.
Yeah. So anyway, most of those different networks, there's a reason that they call it a pi, a T, or an L. And a pi is in that case right there.
Okay.
So
That is interesting as well. Not what I was expecting to get out
you
of
weren't. You were expecting some kind of Raspberry Pi answer, weren't you?
that. No, but I would have been satisfied with that.
Yeah.
What happens when the impedance of an electrical load is equal to the output impedance of a power source, assuming both impedance are resistive? A, I'll make sure I read that right. A, the source delivers minimum power to the load.
B, the electrical load is shorted.
C, no current can flow through the circuit.
Or D, the source can deliver maximum power to the load. Let me read that question again.
Yeah, that's what I was doing a while ago, and I hesitated.
What happens when the impedance of an electrical load is equal to the output impedance of a power source, assuming both impedances are resistive? So that would be like I've got a load like an antenna is hooked to an output of a power source like, say, a transmitter, and both of them are equal impedances. Well, I'm going to say it's D. The source can deliver maximum power to the load.
Mm-hmm.
And I think maybe we even talked about that in the last couple of episodes.
We did.
Okay. So it's not A, B, or C. It's just D. You know, when you've got impedances all the way across, the source and the load both have the same impedance, and particularly when you got a transmission line between the two that's the same impedance, then you're really delivering maximum power. So it's D, although they don't have the transmission line in the question here. Yeah, it's D, and everybody got that over in the chat room there. So,
Well, good job, chat room. They nailed it.
okay, I've got another one here for you.
Uh-oh.
What should be the impedance of a low-pass filter as compared to the impedance of the transmission line into which it is inserted? A, substantially higher.
B, about the same.
C, substantially lower.
Or D, twice the transmission line impedance. Okay, what should be the impedance of a low-pass filter as compared to the impedance of the transmission line into which it is inserted? Okay, those should be about the same. Be about the same, because you wouldn't want to put something that the impedance was so different in the same line.
Okay.
That's my answer. I think it should be about the same. B.
That's what they're saying over in the chat room. I kind of agree with you.
It seems
on
like
that
a
one,
really
too.
bad idea to insert something in the line that's
Totally different impedance.
yeah.
Yeah, it wouldn't seem reasonable, would it?
Nope.
There you go.
Okay.
About the same.
About the same. Which of the following is a reason not to use wire? Okay. Which of the following is a reason not to use wire-wound resistors in an RF circuit? A. The resistor's tolerance value would not be adequate for such a circuit.
B. The resistor's inductance could make circuit performance unpredictable.
C. The resistor could overheat.
Or D. The resistor's internal capacitance would detune the circuit. Which of the following is a reason not to use wire-wound I can't say it either.
It's a tongue twister.
Wire-wound resistors in an RF circuit? The resistor's tolerance value would not be adequate. Well, we don't know what the tolerance would be. D. The resistor's internal capacitance would detune the circuit. I wouldn't think there'd be much capacitance in a wire-wound resistor. C. The resistor could overheat. No, not if you have one of the proper wattage. So B. The resistor's inductance could make circuit performance unpredictable. I'm going to say it's B. Everybody else is saying that.
Yeah. Even my limited knowledge, I think it's B also.
Well, let's see. And it is B. A wire-wound resistor. I just so happen, as a coincidence here, some wire-wound resistors right here that we can look at.
You
Isn't that a
have pretty
coincidence?
much everything here.
I got some stuff here. Boy, I think I was doing better before I put the paper up there. These are two wire-wound resistors right here. Boy, these are 2 ohms. No, 20 ohms. I can't read. 2.0 ohms.
Okay.
A couple of 2 ohm resistors there. You can actually see, if you look close there, the wire turns or wire wraps that are
I
in
see
there.
them.
Looks kind of like an inductor, doesn't it?
It does. I guess it kind of is.
It kind of is an inductor. So yeah, you wouldn't want to use wire-wound resistors in a circuit where the inductance would matter.
Right. And so when I was building, and I guess some of you have probably seen Amateur Logic, and some of you may not have yet. But I built the scope tap, and I built a dummy load inside of it. And well, I had a hard time finding the resistors, and I wanted to get some similar to this here.
Yep.
And they're also wire.
Yeah. These are wire-wound as well.
Yeah, so I was trying to figure out why. It said don't use those, and then it kind of dawned on me what the reason was.
Yep. You don't see the coils in this one, but if you tore out that little filler here at the bottom and looked up in there, yeah, it's coils of wire in there, resistive wire that make up that resistor. A lot of your power resistors are going to be wire-wound types.
And you can get a lot higher wattage of these than you can in just a standard
carbon,
little
yeah.
resistor. So I was having a hard time finding them, but these are pretty plentiful at like Fry's and things like that.
Yep. Here's another one right here. This is a 7K ohm, and it's a wire-wound resistor as well. And then I got one other one here that's always was sort of a curiosity to me.
Oh.
This is a 4 ohm wire-wound resistor, and you probably can't see it there, but there's individual, turns of wire there. 4 ohms.
Oh, wow.
I got this, and it was with a speaker switch panel from, I believe it came from Radio Shack or either Lafayette, one of those two stores. And it was like a bunch of selector switches for different sets of speakers. And it came with these 4-ohm resistors that you would wire up in there. So whenever you flipped a speaker out of circuit, it would put resistors in its place to try to keep the impedance matched on the amplifier.
Oh.
And, I always thought, well, is it really a good idea to be putting a wire wound resistor, in there that's possibly going to put some inductance into your, your audio circuit? And I think it's not a real good idea, but, that's what came with the speaker switch.
Interesting.
So
did it cause a problem?
not that I know of.
Just not a good practice to do it.
I wouldn't think it was a good
It seems
practice
like
to do
it could possibly cause some problems.
Well, audio is an AC signal, and, inductance can have some effect. Now, it might have been so little inductance there that it just really wasn't going to matter, and I suspect that must have been the case. I think the bigger situation was that if you had this panel there that had like 4 or 5 sets of speaker selector switches on it, and all of them had these dummy load resistors on there, you'd be wasting an awful lot of power just heating those resistors.
Oh, yeah.
And you wouldn't be having as much going to your speakers. So, yeah. But, for some reason I've hung on to that resistor there over
And now
the years.
you know why. You
Yep.
were able to pull it out here.
I knew, I was thinking about, probably about 45 years ago when I got that resistor that I would one day use it in a video.
Yeah, and there you are.
On the internet.
Third anniversary.
Yeah. Okay, we can move on to, another question here. This one's a little different. Which of the following is an advantage of ceramic capacitors as compared to other types of capacitors? A, tight tolerance.
B, high stability.
C, high capacitance for given volume.
Or D, comparatively low cost. They are cheap. I know you can. Which of the following is advantage of ceramic capacitors compared to others? Comparatively low cost. They're dirt cheap. You can buy, like I just bought a kit of these things, and there's probably 1,000 of those things in it for nothing. So D is definitely a contender. I'm not sure about the other two. C, high capacitance for given volume. I just don't know enough about that to know if that's the answer. High stability or tight tolerance. I don't know. I haven't done enough with the electronics to know the answer to those. I do know that they're dirt cheap.
So based on that,
The reason I know is because I just bought a whole bunch of them. So based off of that, I'm going to go with D, low cost. But I honestly don't know if that's the answer or not.
well, let's see.
I would think the tolerance and the stability would probably be fine on them, though. But
There you go.
Okay, so that is the answer. And like I say, they're like free almost.
Yep. That's a ceramic disc capacitor right there.
So so let's talk about those what were high stability and tight tolerance. What are the better ones for these? Because I've always heard that these electrolytics right here were not the best for being tolerances.
Well, it depends on, all these capacitors have their own uses here. These ceramic disc capacitors, you're not going to find like a 1 microfarad ceramic disc capacitors. They're going to be smaller values, and they're cheap. They're really cheap. They're probably not the most stable, but they're used a lot because they're cheap.
What is the most stable?
Well, out of these right here, it depends on, they've all got different purposes, like this electrolytic right here. There's a lot of different styles of electrolytics. This one right here, I can't even read it. It's a 1,000 microfarad 35 volt capacitor. This is polarized, it's got a negative and a positive lead on it. But these are going to be for generally like 1 microfarad and above.
Okay.
You might find a half microfarad electrolytic, but most of the time your larger values of capacitance are going to be electrolytics. And that's the reason you use them, is you're trying to go for a larger value of capacitance.
Okay. So these, I know these come very small because I got some picofarad, very, very small. And some of them are just tiny, like a match head.
Yep. All right, so real small stuff, yeah, that would be good. Larger values of capacitance, like, power supplies, audio circuits, and all that, you're probably going to go with something like an electrolytic. Here's another one here. These are referred to as orange stripe capacitors. This one right here, it's a polyester capacitor, a polyester and aluminum foil film capacitor. And these are pretty popular, especially in older, higher voltage gear. You'll see a lot of these in those. They were pretty good quality. They're pretty decent quality capacitors. And most of them will go like with a higher voltage range. This one here, I think maybe that's like 400 volts. It'll go. It's smaller values though. You're not going to find, the same values you would with an electrolytic on one of these orange drop capacitors.
I've seen these fail a lot.
Those will fail a lot.
Usually they, well, where's my camera? They'll swell right there at the top where the little cross is. Or you'll see oil leaking out of them.
Yep. So they can. All right, now there's a couple other capacitors here. Now these are the higher quality ones. Better tolerances, higher stability. This one right here is called a polystyrene capacitor. I think it's got polystyrene material and aluminum foil in it. These are also smaller value capacitors, but these are very high quality. You will find them a lot in audio circuits and things where they really want a high quality pure capacitor that is real stable. These are pretty popular for that. This one right here is a silver mica capacitor. And you can't really see it because of on the camera here, but this is sort of a maroon color. These are in smaller values too, sort of like the ceramic disc capacitor up here. And that range, usually, they'll handle higher voltages. This one right here is good for 600 volts. It uses silver and mica in it. High stability, high quality, good tight tolerances on it. You'll see these used a lot in RF circuits.
Okay.
You'll see them in amplifiers and transmitters and such, or receivers. Very, very stable capacitors. So out of the ones we're looking at here, these two are probably the best, the polystyrene and the silver mica. This is the cheapest, would be the ceramic disc. It's about the same value or ranges of that silver mica. This one here and this one are generally about the same value ranges, with the polystyrene being the better of the two. And then this one, stability, you can buy some with tighter tolerances, but generally you don't really care on that high a value of capacitor. If it's in the ballpark, that's probably good enough. You just need, when you're using something, this high capacitance, you just need something that's, can do that high capacitance and take the voltage that you're working with. Sure, they will dry out. There's an electrolytic dielectric in here that will dry out with age, and these will swell up and short.
I've seen that. I've had to replace some that's happened before.
But if you need something with a higher value, that's probably what you're going with is an electrolytic. They're very popular. A tantalum capacitor would also cover a lot of those, the lower microfarad ranges, 1 through maybe 10, maybe 20 microfarads. They're smaller than this, but they have the same problem. They'll dry out and go bad as well. So there's a little lesson on a few different capacitor types there. Really, which one's the best? Well, it depends on what you want to do. If you want to build a lot of something cheap,
If you want to buy a whole bunch of them for a couple of bucks,
Yeah.
that's the one, because I can testify to that, because it hadn't been long
Yeah.
since my package came in with those in
yeah,
it. I mean, I'm not kidding. They were like just a few bucks for a ton of them.
yeah. If you're rebuilding your vintage audiophile stereo amplifier, you probably might want the polystyrenes. You'll certainly have to replace some electrolytics too in older gear, because those will have gone bad. And then for your RF stuff, silver micas are going to be the best. Well, that's all the questions for tonight.
No way.
got
It was
through
just
that.
getting wound up.
Only one buzzer,
One buzzer.
and I'm glad I was able to present that here tonight on the show as the last one of the year.
We appreciate you for doing that too.
Yep,
'cause,
promise. There will be no more buzzers till 2018.
Yep. You can pretty much count on that.
Yep. Hey, I guess this will be the last time we talk to y'all till next year.
Yeah. When are we going to shoot or
Amateur
Amateur
Logic?
Logic?
Is it second weekend of January? Couple
Yeah.
of weeks?
So catch us then.
Yep.
That would be 2 weeks from tonight.
Mm-hmm. It'll be like a whole different show.
Be like a whole different year.
Yeah. Whole different episode.
Yeah. So anyway, though, those of you that watch Amateur Logic can catch us back here for that.
Yeah, those of you who aren't watching Amateur Logic,
You should catch
You
us
should.
back here for that.
yeah, if you like this one, you'll like Amateur Logic too, no doubt. All right. 7-3 guys and gals, thanks for joining us on Ham College here this past year and the 2 years previous. We're looking forward to a great 2018.
Yeah, looking forward to the 4th year. Yep. Have a happy New Year. I hope you had a great Christmas. And we will see you next time. 73.
7-3. Good night, y'all.
Ciao.
Happy New Year.
Yep. Happy New Year, everybody. Don't drink and drive.